Let's get started. So, hi everyone. My name is Gaurav. I'm a program manager in the Azure Data Factory team here at Microsoft. I have with me my colleague Sandy, who is also going to be presenting during the second half of this session. And together we're going to talk about what are the capabilities, new capabilities of data integration that we have released in Azure. And the way we want to structure this session is that we want to talk about the data integration scenarios first that we have come across while working with our customers. Then we'll give you a brief overview about Data Factory and what it is and what you can do with it. And then we have some exciting demos lined up. We'll spend some time in the end talking about roadmap, and we'll leave 10 to 15 minutes in the end for question and answers. With that, let's get started with the first thing. What we have seen by working with our customers, our partners, developers like you, is that most of our customers fall into these three buckets. These are the three common data integration scenarios. It doesn't mean these are the only ones, but most of our customers that we've been working with, our partners, fall into these three buckets. The first one that we have seen most common is modern data warehouse for BI. So if you look at this picture, and as you all are aware that the volume, variety, and velocity of data is changing. So if I start from the left, you can see that you have your structured data, you have your unstructured data in the form of log files, and it is truly about hybrid data integration, meaning that you have data on-prem, you have data in the cloud, and you're using Data Factory to ingest their data into your storage, and essentially doing some prep or transforming the data in a compute like Azure Databricks, and essentially loading your warehouse. And you could have AS cubes on top of it to build your semantic models to get that subquery processing time, and you're essentially serving that into your Power BI dashboards or Splunk or Tableau dashboards. And this entire pipeline that you see has been orchestrated, can be orchestrated using Data Factory, and you can schedule it, monitor it from a single pane of glass. So this is the most common pattern that we have seen where customers are looking to modernize their data warehouse for business intelligence. The second one that we see across a lot is the SaaS apps, where customers are looking to modernize data warehouse to essentially build their software as a service applications. And if you look on the left side over here, the pattern is pretty much similar to the previous one, where you have structured, semi-structured data. So basically data of various forms and shapes, and again, loading into storage, cooking the data, prepping the data, transforming the data, and loading your app storage. So instead of the data warehouse, it is loading the app storage, which is the backend for your SaaS apps, and the customers are rendering those SaaS apps in browser or in a mobile device using iOS apps or whatever. So in this particular scenario, take an example of Adobe Marketing Cloud. So they are essentially gathering data from a bunch of their partners, and they're essentially ingesting the data, storing the data into the lake. They are prepping the data, they're loading the app storage, and all of their customers who are using Adobe Marketing Cloud platform are getting served using this platform. The final one that we see most common, and this is for the customers who have kind of invested in the SSIS, in the ETL packages for last decade or so, and looking to see a way forward in Azure and see how they can lift and shift their existing SSIS packages to cloud. In here, cloud means Azure. And here they want to continue to use their familiar tools like SSMS, SSDT, and build their packages, but at the same time do not want to be in the infrastructure management business anymore. So they want to use the power of Azure, they want to use pay-as-you-go model, and take their SSIS packages and execute them in Azure. And we're going to be covering a lot about this in the second half. My colleague Sandy will go deep into it and some of the exciting stuff that we have done here. But we have also seen a lot of customers falling into this bucket as well. So with that, if I were to take these three patterns and explain what Data Factory is, Data Factory is a managed data integration service in Azure, and it provides three main value props. The first one is that it has a flexible pipeline model, which means that you can have your activities connected to another activities. They could be running on success, on failure, on completion. You could have loops, you could have iterations, you could have conditionals like if-else. You could be triggering your pipeline on demand or on a schedule or on an event like a file arriving on your Azure Blob storage. So all of these control flow aspects, if you will, are today supported in Azure Data Factory. The second most biggest value prop with Data Factory is that we have a data movement service that sits underneath us, and this data movement service is truly elastic. It is truly serverless, meaning you just come in, provide your configuration, and we will automatically create the infrastructure in the backend to scale up based on your data movement, based on your configuration that you require. And we are smart enough also to understand which data movement, which region you're doing the data movement in, and we'll automatically instrument the data movement service in that region. Then the third one is, as I explained during the scenarios, is the SSIS package executions. Data Factory service today allows you to lift and shift your SSIS packages and execute them in Azure. So if you have made a lot of investment on those and looking to use the power of Azure, you can do that with Data Factory today. And for all these three value props that I talked about, you can essentially use our tools, authoring and monitoring tools, to build these. You can use drag and drop interface. So we have visual tools now, and I'll go more into that detail when I show you the demo. We have all the programmatic interfaces like every Azure service does. So you want to use Python, you want to use .NET SDK, you want to use PowerShell, you want to use ARM templates, REST APIs, all of that interface is available for you as a developer to use. So if I were to dive deeper into Data Factory and talk a little bit about the architecture and what we have done. So if you look on the top here, you have your Data Factory service running in Azure, and you have your UX or SDK using which you can build your pipelines or an SSIS package. So there are two things you can author in Data Factory. Either you author a pipeline or you author an SSIS package. And this Data Factory service is responsible for scheduling, orchestrating your workflows, and monitoring your workflows. And then we have what we call as an integration runtime. Think of this as the heart of ADF. So this is the ADF's execution engine, and it provides three capabilities today. The first one is that it allows you to do data movement. With data movement, I want to take a segue and explain there are two types of integration runtime that we support today. We have the Azure integration runtime. So this is the one that gets automatically provisioned when you provision your Data Factory. And we are responsible for scaling it up and down automatically. You don't have to worry about it. You just come in and say, I want to move data from, let's say, Azure Blob to SQL DW. We'll scale it up, scale it down based on your needs. And this integration runtime, we also have a capability where for data sovereignty reasons, you want to come in and say that I want to make sure that my data always gets routed through Northern Europe. So you have the ability to create this integration runtime in a specific region as well. Then the second form of integration runtime that we have is what we call as a self-hosted integration runtime. And this integration runtime is a piece of software that you install on a machine that has direct line of sight to your on-prem environment and to Azure. So anytime you want to do hybrid data integration, you will use the self-hosted integration runtime. And this integration runtime can be installed in Azure or any cloud that you want. This has a capability for you to create a network of VMs. So it's not a single point of failure. So you can have up till 4 VMs. They run in a round-robin topology in an active mode when the jobs are being scheduled. So if one node were to go down, the next one would pick up. And with this self-hosted integration runtime, it is all outbound. So there's no inbound connection that we are making over here. And so this can be installed in different topologies. It can be behind your firewall. It can be on an ISVM in Azure. Like I said, the only requirement is that the machine needs to have direct line of sight to your on-prem environment and Azure. So The data movement piece is the key. The second one is the pipeline activity execution. So you can tell your integration runtime that I want to run this Spark activity on Azure Databricks. I want to run this Spark activity over my HD Insight compute. I want to run this custom activity over Azure Batch. And this integration runtime will automatically be able to do it for you. And the third one is the new capability that we announced last year, where you can use a flavor of this Azure integration runtime to essentially execute your SSIS packages in Azure. Couple of points that I want to make over here. As you can see, there is a command channel and there is a data channel. And this is a very important point because when you have a data factory, let's say in West US, and let's say you're trying to move data from your on-prem environment in, let's say, Canada to your, let's say, some blob storage in Canada, then your data is not coming from your on-prem environment in Canada first to your data factory in West US and then back to Canada. It's directly going from your on-prem environment to cloud. So this is a very important point, and the data movement service today is available in 20 plus regions around the world. And it can, like I said, in case of Azure integration runtime, it can scale up and down automatically for you. So let's take an example over here, and I want to show you a capability where how can you build your pipelines for modern data warehouse for business intelligence. And for this, I want to actually use an interesting example of what we call as IROPS. So the airline industry has this problem, if you will, where there are irregular operations that are happening. So last year in December, I was passing through the Atlanta airport and the power suddenly went out and we were stranded on the airport for like 15 hours. And the reason for that power outage was the grid system actually failed and the backup didn't come up. But that outage could have happened due to a storm or whatever reason. So this airline IROPS, irregular operation, is actually a real problem for the airline industry. And this is actually a $60 billion airline industry spend every year, different airlines, on to solving this particular problem. Because imagine when an IROPS happen, then you have to rebook a customer's flight, you have to rebook a flight for the crew, so there's cost involved in that. And plus, what has happened over here when I was passing through the Atlanta airport, that if we were to go to the kiosk and I was traveling through Delta, the professionals over there knew nothing, and we knew before that what has happened because we were able to find it out through the social channels. So I'm going to use this example to explain that how you can use hybrid data integration, how airlines and they can empower their staff to use hybrid data integration to actually get data from on-prem sources, from social channels, and reduce the reaction time for their customers. And not only they can do that, but they can also do personalized communication to enhance their experience. Because I'm a high-valued customer for Delta. I have like 75,000 miles. So even myself or high-valued customers like those didn't have much information. So imagine a person who's traveling for the first time, what would happen to them? So using this example, I'm actually going to go a little bit backward and first show you the actual Power BI dashboard that an operations manager can use. And then I'll show you how all of this can be built using Data Factory and all the other Azure services that we have in the modern data estate. So you're looking at the Power BI dashboard, and think of it that you are an operations manager and you are monitoring the KPIs for your flight punctuality, your customer satisfaction. And suddenly you notice that there's a severe weather that's hitting the Atlanta Jackson airport. You can also see that the tweet count is going up for people tweeting about that airport. You see a lot of tweets by hashtags saying snow. So in this case, we are using the weather example that due to weather, there's going to be a power outage. And these are the upcoming flights that are going to come to the Atlanta airport and the passenger load factor. So based on this, you can, as an operations manager, you can pretty much determine that there is essentially an IROP situation happening over here. And you can look at other indicators to detect and monitor that IROP. So you can see that the severe weather score is high. You can see the traffic is actually jamming up near the airport, so a lot of people are blocked in traffic. You can see the 3-hour forecast is not looking good. And again, you can look at the social hashtags that are coming from Twitter. These are real tweets that customers are tweeting, and you're getting that input. And this is the gate status where you can see that a bunch of flights are starting to get delayed. So you as an operations manager at this point are pretty much certain that there's an IROP situation happening. So as an operations manager, what you can do is run an impact analysis pipeline, if you will, and you can determine that due to this IROPS, these many flights will get impacted, arrival and departure flights. This is going to have a domino effect because if Atlanta, as you know, is one of the biggest and the busiest airport in the US, and if the flights over there are going to get delayed, so connecting flights are going to get delayed as well. And you can look at now, categorize your customers to say, these are my high-valued customers that are getting affected, my leisure, my premium customers, and special assistance ones. And you can look at the customer level by status. So you ran an on-demand impact analysis pipeline, and you're able to see all of that information. And then you can essentially look at the high-valued customer analysis. So you, as a high-valued customer, if you want to look at those and see that these customers, how many of those customers are getting impacted, how many of those have been contacted already, have not been contacted. In terms of lounge, my Delta Sky Club lounge is already filled, so how can I route my passengers to other lounges? Or I can look at the customer check-in status or the available accommodation so that I can actually send my customers over there because I know the flights are going to be impacted and I have no new flights to put them on. And once you do this, then you can essentially do the second part of it. So you reduce the reaction time by building those pipelines, and then you can essentially do personalized communication. So you can essentially reach out to your customers and say, oh, the flight is getting impacted and we are aware of the situation. We are working hard to resolve it. You have been booked on this hotel and we are giving you so-and-so voucher. So you can do personalized communication for that. And then after all of this is done, you can do post-impact analysis to see how you can actually improve this going forward and make it easier for your customers and learn from this situation. So if you look at this, is typically following the example of any incident that might happen in our service, where we have an incident, we work to determine the impact, we work to resolve that, and then we essentially do a post-mortem analysis. So this is essentially following the same pattern. So now let's go back and see how all of this can be built using Data Factory and other services. So this is the Azure portal, and as you guys are all aware, Data Factory is live over here under Data and Analytics. So if you go under Analytics, you can see Data Factory over here. You can build your Data Factory and pin it to your dashboard. So I've already done that. So I already have a Data Factory called as Airline IROPS Data Factory that I have built. And you'll get a blade like this after you provision a Data Factory. And this is the author and monitor tile. So you have some monitoring information about your Data Factory and this author and monitor tile, which when you click, launches this brand new UX that we have built ground up and we launched back in January. With this UX, you can essentially build your pipelines. You can iteratively build, debug, deploy, monitor all of that without writing a single line of code. So you will essentially reach to this overview page where you have some quick actions to get started. We have spent a lot of time building these tutorials. So these are step-by-step instructions on how you can essentially use this new visual tools that we have launched and some more information about that. So you can essentially use one of these quick actions to get started. So you can say create pipeline, and at that point, you have your Resource Explorer on the left, which is listing all your pipelines and your data sets, if you will. And think of data sets as just a glorified variable. So we as a Data Factory do not store your data. We're just pointing to your data in the storage, whether it is in Azure storage, it's in Data Lake store, wherever it is. And This is our toolbox. So we have 20 activities here, and this continues to grow. The way this is organized is that you have your activity, which runs on which service. So custom activity, which means you can write any .NET code, runs over Azure Batch. We have Notebook, which runs over Azure Databricks. And the entire HD Insight family, some iterations and conditionals, and some activities like stored proc, web activity, and all of that. So what I have done is I have already built a pipeline, which I'm calling as ingest and prep data. So what I want to show you over here is that you can see that I'm actually gathering data and empowering the airline employees to not only join the social data, not only get the social data, but also join it with some customer information that could be in Salesforce or in Dynamics. So you can see over here that we are getting the weather data, we are getting the delayed flights, we are getting the customer information from Dynamics, Salesforce, we have the crew information in SAP HANA, and we have the tweets coming in real time, which we are doing some prep. So here you can look at, let's say, for example, let's look at Salesforce. And if I were to go above, you can see that I can look at quick previews of the data. Over here, I can look at my Salesforce data to tell exactly what is the customer information that's being pulled up, which will be joined with my other data. And these are all configurable layouts, as you saw that I just full screen them. And this is just some customer information that we are pulling up from Salesforce. And here, like I said, we have these information, but you as a customer can essentially pull data from 70 plus data sources that we support today. So all of these are available over here. And these are organized, like if you want to say Oracle, so all of the Oracle ones are supported over here. You want to say HANA or SAP. All of these are supported. So 70 plus, and we'll continue to increase this. Bottom line, you can essentially use any of those wherever your data is. And after I grab the data, you can see that the way I have set up is that if any of these things fails, I want to send a failure email, or if it passes, then I want to call my Databricks notebook, where essentially I'm doing some data prep. And once I do that data prep, so essentially all I'm doing is shaping the data and using Databricks as a step in my pipeline to do that. And then I'm calling an impact analysis pipeline. And this impact analysis pipeline is another pipeline that I have built. And in this, I'm doing is I'm getting the process tweets from social channel. I'm analyzing the sentiment to see whether it is positive, neutral, negative. And then I'm determining the impact of weather, I'm determining the impact of flights. So you can see over here that how I'm able to truly do hybrid data integration, grab data from different sources, combine all of it together, and empower the airline employees to essentially reduce the reaction time, and not only do that, but actually provide personalized communication to their customers. So this is one example that I use, but you can see that this can be replicated across different use cases in different verticals as well. And here, once you run this, we have cool features where you can essentially say that I want to put breakpoints, so I want to just run up till here and just only debug this information. So I can actually provide the variables over here and say, yeah, run this. So it will only debug up till this point, and the real-time information would come over here. And you can look at the real-time information as the stuff is in progress as well. What we also have is, if you are comfortable and you want to run this on a schedule or an event, you can essentially say, I want to define a trigger. So I've debugged this pipeline, everything runs as per my requirement, and I want to essentially run it on a trigger. So you can come in and use any of the triggers that we support, whether you want to run it on a schedule. The difference between schedule and tumbling window is schedule is now to future. Tumbling window allows you to go in the past and do backfill scenarios as well. And then we have an event-based trigger where if your file lands on a blob and you want to start a pipeline, you could do that as well. Another thing over here is that what we have built this interface is with usability as key in our mind. So once you are building this, you can validate this entire stuff. So let's say if I were to just drag a notebook activity over here and click validate, it will tell me exactly what's missing, and you can click this and it will take you exactly to the location, what is missing, and you can click that. So generally customers would just build the workflow, click validate, and keep filling that. So if I select this, you can see this got succeeded. So keep filling this and build their workflow, debug it, then deploy it to their data factory. What we also have with this interface is you can essentially hook it up to a Git repo, which means that you can essentially have a VSTS Git account hooked up to it, and you can, all your JSONs, which is the code representation of your data factory, can go in VSTS Git, and you can do collaboration, source control, continuous integration, and deployment with that as well. So once you have built these pipelines, you can essentially monitor them. So as you can see over here, that I have these runs, and I intentionally failed them because I want to show you that we have information about all of the runs that have happened. So each row is a pipeline run, and inside a pipeline run, we have activity runs. So this is a pipeline run, and if I click the actions column, I can see the activity runs inside that pipeline, and you can see that all the copy activities that we had from different sources passed, and then my prep tweet data failed, which was a uSQL activity that I was running, but my Databricks execution passed. And I can look at all the details of this activity in terms of runtime, duration, and all of that as well. So this is a single interface where you can monitor your entire pipeline as well. So you can essentially create alerts on failures. You can essentially look at your metrics to say what is the successful runs, failed runs, and all of that. So all of that information is available for you to use. So going back to the presentation, yeah, so as I mentioned, this, whatever pattern I showed you can be replicated across different use cases in different verticals. And the way I showed you is a pipeline which typically looks like this, and it can go as complex as it wants. You have your trigger, which can be event, wall clock, or on demand. You can pass certain parameters, start an activity. If that activity succeeds, can run another activity, or if it fails, it can go send a failure email. This activity too could be generating a list of files, and that could be passed to a for each loop, and it is going over each file one by one and triggering another pipeline. The piece that I talked about when I was talking about Data Factory was data movement, and which was one of the biggest value prop, and we have a data movement service that sits underneath this. And it is essentially three main things I want to talk about with respect to data movement. That the service is truly scalable, which means it has per job elasticity. There's no noisy neighbor problem because you get a dedicated infrastructure to run your jobs. We'll scale it up, scale it down. And in certain cases, we can give you up till 1 gigabyte per second as well. So if you're trying to load your data warehouse, we automatically, behind the scenes, will use Polybase. Or if you're trying to load from, let's say, Amazon Redshift to Azure Blob, we'll automatically do what we call as unload scenario, where we'll load from Amazon Redshift first to S3 and then to Blob, because we know that's going to give you the maximum performance. And all of this is going to happen behind the scenes. Data Factory as a service will take care for you. You will just come in and define your configurations to say, I want to move from Redshift to Blob, and we'll do all that magic for you. The interface to build this is simple, and it's serverless. There's no infrastructure to manage. You can truly ingest data at scale from 70+ data sources that we support. And like I said, we have 20+ regions where this service is present, and we have the self-hosted integration runtime that I talked about earlier to do hybrid data integration. I just listed different categories and the connectors that we support. All of this is available in our documentation as well. We'll continue to increase our connector footprint as we move along, and we have a goal to double, triple this in the upcoming months. So I talked about data movement, and I want to show you a quick demo with respect to data movement. So the Data Factory, once you land on the overview page, so right now, if you were to build a pipeline, you need to understand what a pipeline is, what an activity inside a pipeline is, what is a link service. So essentially, link service is nothing but a connection string to your store, to your compute. But if you don't want to understand all of that, and you want us to abstract all of that away from you, what we have is what we call as the copy wizard. And you can essentially use this copy data tool to just provide the configuration, and we will automatically create the pipelines, the data sets, the link service behind the scenes for you. So what I'm showcasing here today is that I want to load data to my Cosmos DB. So I have launched this copy wizard. I'm creating a Cosmos DB pipeline, running once. I can run once or run it on a schedule, totally up to you what you want to do. So let's say I want to do run once. I'm selecting an already existing connection, which is Azure Blob. Going next, and it's going to tell me the information about my Azure Blob. I can select my input folder. So essentially, I can browse my Azure storage and select my folder. In this, once I do that, we can say, because my data is in JSON format, so I've just selected that JSON format, and I want to just export as is JSON files to the Cosmos DB collection. And you can look at quick previews of the data. First 10 rows we display for you. I'm selecting my Azure Cosmos DB as the destination. And once I do that, it will automatically go connect to that Cosmos DB. It will load all the collections that I have over here. I can select my demo table. And at this point, I am presented with the settings. So you can keep this auto, and we will try to determine automatically. We are using some machine learning technologies behind the scenes and learning from your data to see how we can auto-magically scale. But you know your data better, so you can come and select this cloud units. And think of these cloud units as a unit of processing power compute. And this is essentially that scalability factor. So I've given me the max one that I want to choose. At this point, I'm looking at the summary, and once I click next, at that point, my pipelines would start to create and run. So at this point, you didn't have to understand anything. We just automatically created all the pipelines for you. So we create the pipeline, and if you wanted, you can essentially augment those pipelines to do other stuff. So as you can see, the Cosmos DB pipeline was created. If you wanted to add a Databricks activity next to it, you can just drag and drop it. You can connect it. So it's all drag and drop, no code required. And once the run completes, so as you can see, this one is in progress already. So I have some runs that I already did last week. So you can see that for this one, I have this copy activity that run, and we present you all the information now with respect to the copy performance. So you can see over here that essentially I moved 100 gigabyte of data from Azure Blob to Cosmos DB, and this is one of the connectors that we have worked to improve the performance a lot. We have actually increased the performance 10 times for this. So I was able to load 100 gigabyte of data in close to 10 minutes, and it tells you how much time it was in queue, how much time actually the transfer took, the data movement units, and the parallel copies that I used for this. So all of this information is presented to you, and you can use that. So going back, you have, so like I mentioned, we have worked to improve the performance of some connectors that we support, and we continuously work on increasing the other ones. I talked about Azure Cosmos DB and showed you a demo. We have increased the performance 10 times. You can essentially scale it to use 100% of the request units that the Cosmos DB supports today, and it's reliable in terms of data movement as well. The second one is if you're trying to load data into Azure SQL DW, like I said, we'll automatically use Polybase behind the scenes to load the data. If that's not possible for certain connections that you're using, we'll switch to bulk insert mode, and the criteria is mentioned, and I have a link in this presentation as well. Similarly, if you're trying to load Azure Blob or SQL DW, if we figure out that loading, so if we know that we can use Polybase from Azure Storage to SQL DW. So let's say you're trying to move data from Amazon S3 to SQL DW, then we will behind the scenes first load your data to Azure Blob and then to SQL DW. So we are quite smart over there. And I already mentioned about this Amazon Redshift scenario that we are doing what we call as unload. So we have data movement security. So we support different types of authentication over there. We have support for basic auth, Windows auth, service principals, and we started supporting MSIs as well. So every data factory has its unique identity, and then you can use and pass that identity across using MSIs. Then for credential management, all of your credentials now can be stored in Key Vault, and you can look. So if I were to show you over here, you can essentially go to connections, and if you're creating a connection to any of these stores, so let's say Amazon S3, so you can essentially use the access key, or you could refer to Key Vault, and we will automatically refer to your credentials in the Key Vault. Then in terms, and we can manage those as well. If you don't want to use it, we can manage those. If you're using self-hosted integration runtime, we can encrypt those using Windows DPAPI. And in terms of transit, data in transit, we use HTTPS, TLS. If your data is at rest, you can use SQL TDE. You can use storage, SSE encryption that they provide. And like I mentioned earlier, in terms of network security, it's all outbound connection from the self-hosted integration runtime when you're doing hybrid data movement. There's no inbound connection that's coming, so it's truly secure in that sense as well. So next, we're going to go over SSIS in ADF and talk about some of the interesting things that we have done, and Sandy is going to walk you through those.
Thanks, Gaurav. So with SSIS in ADF, I will start with a recap. As you know already, SSIS is a traditional ETL tool that always comes bundled with SQL Server on premises. It's been around for almost more than 10 years now. And along the years, we've been adding features on running SSIS on premises. For example, last year with SQL Server 2017, we have SSIS being able to run on Linux, so Windows and Linux. In terms of scalability, we have added a scale-out feature where you can actually install multiple machines and run it in the master worker topology. But here, you still have to manage your own infrastructure. In terms of edition, you have a standard and enterprise edition, where enterprise edition will allow you to use advanced premium components within your packages. In tools, you have the traditional SSDT and SSMS to design, deploy, manage, execute, and monitor those packages, right? And extensibility, we have ISV, a lot of ISV out there that build an ecosystem of SSIS components that run on premises. And in terms of pricing, it comes free, but it's actually bundled within the SQL Server pricing. Now, last year, in October, at Microsoft Ignite, we launched a new way of running SSIS in the cloud, which is integrated with ADF. So in here, when you run SSIS in the cloud, you actually bring your own database to host your catalog of project and packages, which is SSIS DB. In here, you have the ability to use either Azure SQL Database or Managed Instant, which is a flavor of Azure SQL Database that has almost 100% backward compatibility with SQL Server on premises. In terms of scalability, you use ADF compute resource. So this is one of the paradigm shift. When you run a SQL Server on premises, the SSIS catalog is hosted by SQL Server, and the compute is also the SQL Server. But when you run it in the cloud, we have a separation of compute and storage. So the storage of SSIS packages is actually hosted by SQL DB or Managed Instant, but the compute is actually within ADF. We have this native compute resource, which is essentially a managed cluster of Azure VMs, and we call it Azure SSIS Integration Runtime, or IR. That's exactly the same like what Gaurav mentioned before. The edition in the cloud is the same. You can run a standard and enterprise edition. And the tools, also the same. This is very important because you can essentially preserve the same skill set. So if you are familiar with SSDT and SSMS, you can use the same tool to deploy, manage, and execute packages in the cloud. But with an addition of the ADF UI that Gaurav was showing before, now you have another tool to actually start modernize your workflow in the cloud with an ADF app. And in terms of extensibility, we also introduced a new feature such that ISV can also develop components that can also be installed on SSIS in the cloud. With this, I will talk to you in the later part of the presentation, which is two features that are very important, which is a custom setup and third-party licensing. And finally, in terms of pricing, you'll be charged a pay per hour. Basically, just like Azure VM, as long as the VM is running, as long as the cluster are running, you'll be charged. And then when you want to manage your cost, you just stop the VM or the cluster, right? And then to manage, to to take advantage of the substantial savings, if you already have a SQL Server on premises, and when you lift and shift your packages to the cloud, you can actually use this option, which is called Azure Hybrid Benefit, or AHB, which is essentially bringing your own license to the cloud and get a substantial discount on running SSIS in the cloud. Now, if you have data sources on premises, the way for Azure SSIS IR in the cloud to have a line of sight to your data on premises is using VNet. So VNet is a way for us to enable on-prem data access. Now, when you have this SSIS packages running in the cloud, you can start modernizing it. You can schedule SSIS packages as a first-class activities within ADF pipeline. So suddenly, you can use the ADF trigger that Gaurav was showing before to trigger SSIS package execution. And you can also start combining almost like a Lego approach, combining SSIS activity within ADF pipeline with other activity, which is one of the demo that I will show you later. Okay. And finally, the one that's really interesting is it actually is very complementary in terms of ADF usage. A lot of ADF customer in the first version of ADF has some gap in terms of transformation, because they have to actually code their own transformation. But with the introduction of SSIS, you can actually start splicing or injecting a built-in data transformation, a task that comes from SSIS within your ADF pipeline. So it's a win-win solution for SSIS user and ADF user. Okay. And then Readiness is actually now in public review. We have a few customer, actually a lot of customer actually running production with a 24/7 live support. So now we'll go to an end-to-end demo with first provisioning the SSIS IR, deploying packages into the cloud, executing the packages, scheduling it, and then also monitoring it. All of them will be using the ADF UI. Let me switch. Okay, so you see this is the ADF UI, our app that was shown before. I want to create a new integration runtime. You just click new. You can see there are two flavors of integration runtime. One is for the copy activity that Gaurav was showing before. And the one that we want to create is the one that's dedicated to execute SSIS packages. And you see the provisioning blade. You can give a name and description of it. The type is it's fixed into Azure SSIS, and the location. The location by default right now will pick the location of my Azure Data Factory. Because my Azure Data Factory for this one is actually in West Europe, it's actually suggesting the SSIS IR to be also in West Europe. But this does not have to be aligned. The Azure SSIS IR can be provisioned in a different location than the Azure Data Factory. So you can see we have 8 regions available right now: East US, North Europe, West Europe, East US 2, Central US, Australia East, West US 2, and UK South. And we will keep adding regions every time. Okay. And then in terms of the size of the node in the cluster, we have 6 different sizes, and you can see the specs there. We have all the way from 1 core to 8 cores and different sizes of memory. So if you have a big package that you want to use a lot of memory, like a sorting package, then you use a bigger machine. If you have simple package, you can use a smaller machine, etc. Once you decide on the size of the node, you can actually decide on the size of the cluster, which is the number of nodes. By default, you can have 2 or 1 or all the way to 10. Okay, and essentially, providing a lot of nodes will allow your packages to be executed in parallel. Let's say you have 1,000 packages that you want to run in parallel. If you have 10 nodes, then each node will take 100 packages, and they all can be done in parallel. Okay. So that's a level of concurrency across the cluster. I will show you later in the different blade is the level of concurrency within the node itself. Next, you can choose the edition of the IR, either standard or enterprise. Like I mentioned before, with enterprise, you have this advanced and premium component like Oracle connectors, SAP connectors, etc. Oh, sorry. And finally, this is what I mentioned before. If you click yes in here, you're essentially saying that I have a SQL Server license already on premises, and I want to take that to the cloud. So don't charge me for any intellectual property for SSIS. I already paid for it. So what you need to pay is only for the management of the platform as a service in the cloud. That way, basically, you just pay for the service management without paying the IP anymore. Okay. Okay, let's see. Go to the next. So the next bit is essentially provisioning the Azure SQL DB or managed instance where you want to host your SSIS DB. In here, you can select your subscription. Let's see, mine is this one. And then the location is important. Unlike the independent of location between ADF and SSIS, with the SSIS DB, you essentially, we recommend it to have the same location with your IR. The reason being is because whenever you execute a package, your IR will write execution log back to SSIS DB. So if your SSIS DB is in Europe and your IR is US, those execution logs writing will go across the continent. So ideally, it's better to have like both SSIS DB hosted by Azure SQL and IR by ADF in the same location. Okay, so I'll choose, we have several server there. I'll just choose mine here, for example. Next, this option, which is use AAD authentication with your ADF MSI, what it is. Essentially, this is for like an IT operation where you don't want the operator to actually enter a username and password. So you essentially want to use Azure Active Directory authentication. The way you do it is by basically assigning your ADF MSI. MSI is a managed service identity into an AAD group that have access to your Azure SQL DB. In this case, you don't have to actually submit a username and password, a SQL auth anymore. You just use AAD auth. Okay, let me use the normal SQL auth option. And this is essentially the SQL auth server admin username and password. Let me put, it's my username. Okay. Once you put the server admin credential, you can choose the pricing tier. How big is your SSIS DB you want? If you have like a lot of like operation and you want to save a lot of execution log, you want to use a bigger SSIS DB, for example. You have all the tiers there from basic S0 as all the way to PRS 1, 2, 3, 4, 8 or 6. Sorry. So let's just use S0 for now. And finally, the last option is actually mandatory. Because you are, in this example, I'm using a SQL DB that's a standard, that's actually in the public network. So there's a mandatory option that actually you have to allow the Azure services to access your Azure SQL DB. The reason why is because we need to manage and prepare SSIS DB for you. There are two other flavors of Azure SQL DB where this is not mandatory anymore. One is if you use Azure SQL DB with VNet service endpoint. Essentially, that option allows you to isolate your Azure SQL DB, so only services within a VNet can access it. In that case, when you select that DB, you don't have to allow Azure services to access your DB anymore. The other one is the one, the flavor of Azure SQL DB that I just mentioned before, which is the managed instance. This managed instance is also only a provision inside the VNet. So in this case, allowing Azure services is not mandatory anymore. For us to actually access the managed instance database to manage SSIS DB, you have to inject in the integration runtime inside the VNet. I'll show you like the difference, for example. Let me change the subscription to show you what is a Azure SQL DB with VNet service endpoint look like. Okay, here you go. You see, this is one of my SQL DB with VNet service endpoint. And suddenly you see that the mandatory option to allow Azure services doesn't appear anymore, right? But when you select this flavor, you're essentially obligated to inject or join your IR into a VNet such that it can access the database to create and manage SSIS DB. The other version is the Azure SQL Managed Instance. Let me change the subscription for that. Oh, no, actually, it's a location. It's a different location I have. Okay, let's see. This one, for example. And you can see the difference in the server endpoint. Instead of like you have like a instant name, database.windows.net, you have like another fourth term there, which is the DNS prefix name. That's showing you that this is actually a managed instance server. In this case, you can see you're not obligated to allow your services to access it anymore. And also, you don't have to define the catalog pricing tier, the database pricing tier, because with managed instance, the size of a DB comes with the size of the instance. So that's also not required. Let's get back to the normal one again. I'm just going to use a standard Azure SQL DB in public network. Okay. Now, I put all the information. Then before you can move to the next blade, you have to test the connection to make sure that it works. Give it a second. But takes a bit of a while here. Yes, connection successful. Now the final blade is essentially advanced settings. In here you can essentially decide before the size of the cluster, decide on the parallelization in terms of like executing packages on different nodes, right? In here you can actually decide if you want to execute multiple packages inside a single node. If you have a big package that you want to take advantage of all the cores in the node, then you set the concurrency level per node low, like for example 1. That means like all 8 core will be dedicated to executing a single package. But if you have a very light packages a lot and you actually want to run just one core with one package, then you can increase the concurrency level. It goes all the way to 8 because the maximum core that we have per node is up to 8, right? So for this example, I just choose 1. And this one, the next parameter is very interesting. This is where you actually provide a signal to us that you want to actually customize your SSS IR. This is where when you have your own custom component that you want to run, or you have custom assemblies or DLL that you want to run in the IR, or if you have a third-party component like like Kingsway Soft, Code0 component, what you do is like you provide a SAS URI, a shared access signature uniform resource identifier of your blob container, and in that blob container you can upload a setup script which is main.cmd and associated files, and put the SAS URI there, and then when you provision, essentially we will download all your setup files, execute it, and then make sure that your SSIR is customized. I will go to a deeper demo in that side, okay? And then finally, in here, this is optional if you want to inject the IR into a VNet. The reason why it's optional is because the SQLDB flavor that I choose is a public SQLDB, right? If I choose the other one, which is the SQLDB with VNet service endpoint or managed instance, then this is not optional anymore. You have to actually inject your IR or join your IR into a VNet. You can see here the location of the VNet has to be in the same with the IR. And the type of the VNet, you can have classic or ARM, Azure Resource Manager Virtual Network. We recommend ARM because classic will be probably deprecated in the future. And then once you do that, you select the VNet name and the subnet name. And then once you do that, when you click finish, we essentially will provision your IR inside the VNet. And when you do that, the IR will have either access to your SQLDB or managed instance that also inside the VNet, or have access to your on-prem data access that's connected to also to a VNet, okay? Let me just make it simple without VNet, and then just click finish. Now it's being provisioned. You can see on the monitoring, it's the IR, the compute resource, is being started. It takes about 20 to 30 minutes. So for the purpose of this demo, I will show you the one that's already provisioned, okay? It takes a bit second. Okay. You can see we have 3 IR here. The first one is basically a default Azure IR for copy activity. This is the one that Gaurav was using for his demo. The second one is the one that I just provisioned. It's still in the starting mode. The third one is an Azure SSIS IR that I pre-provisioned before this demo. You can see that it's already running, and you can actually monitor the status of it. You click on the monitoring. You can see there, I have 3 nodes in that IR running, right? All the size of memory, the CPU utilization. I have the type, the location, the size of the node, and also like if it's actually all of them ready, and also the service endpoint. the server endpoint, sorry. When you click on the status tile, you can decide if you want to stop the IR. Essentially, just like Azure VM, if you don't have any more workload, you don't want to leave it running because you'll be charged, right? So if you want to stop it, you just click on stop. And you'll be warned, essentially, when you click on stop and if you confirm it, we will release all the nodes. When we release all the nodes, essentially, the next time you want to start, it will take another 20, 30 minutes. That's why you have to be sure that you don't want to run this, you don't want to run a workload in the next 20, 30 minutes or something like that. Just cancel. The resource ID is essentially, you can copy it. The resource ID of the IR will be used, for example, when you buy a third-party component. You can actually provide your vendor saying like, hey, this is my Azure SSIR ID. I want you to give me a license for it so I can install your component, your premium component, right? And in the server endpoint, you can see here you can copy it. The server endpoint is essentially the connection information that you can plug into SSDT or SSMS to deploy packages. And then you can also, from here, you can go to the Azure SQL DB page to monitor your SSIS DB performance. You can see like the size, like if it's actually filled up already, if you need to rescale your SSIS DB, for example, you have too many execution log, etc. There you go. So let's go going to the SSMS. Now let's connect SSMS. Let me see. Let me connect SSMS to this IR that's already available, right? You can see I put the server endpoint there, Savinari SSIS DB. I put the one important part is like when you connect to SSIS in ADF, you have to make sure the target connection is SSIS DB. When you do that, you connect. Here you can see that now I'm connected to the SSIS in the cloud. You can see there's the SSIS DB prepared already. And inside the IS catalog, I can have all this project and packages. I have already pre-deployed a lot of these packages already. But to wait for you to deploy a new one, you just right-click on projects. This is basically the same skill that you have learned before in SSMS to deploy projects. It will launch IS deployment wizard. You can click and you can pick the project deployment file, which is the iSpec file. And you can see here, for example, I have the PowerShell iSpec or the package that I will show you later. If let's say I pick this one, that's okay. And then it will actually ask to enter the same username and password. Oops. This is using SQL Auth, by the way. I'll test the connection. And you can see in the bottom, is just before it deployed, it noticed that I already deployed the same package, so I won't do that. But that's the way you deploy packages to the cloud, okay? Now, before I actually run everything, let me just show you, now I have some packages. When I click on this package, this package is essentially a very simple data flow, just like the name. It's actually moving data from one table in a SQL DB to another table in SQL DB 2. I'll show you what the source and the destination look like. The source is very simple. It's just like a two-row table, right? The other source is, there are two tables in SQL DB 1. And essentially, I'm moving that into SQL DB 2, where the destination is still empty, right? So the package itself is very simple. You can see here the data flow. Just a data flow from moving data from one table to another. But I actually parameterize it. The reason why I parameterize it is because I want to be able to change the destination from table 1 to table 1, table 1 to 2, 2 to 1, or 2 to 2, or something like that, right? I create a package parameters, which is the name of the table. And then once I do that in SSMS, I can actually create an environment where I can assign different environment variable to the parameter. So for example, in this environment 1.1, it's essentially moving table 1 to table 1. Environment 2.2, table 2 to table 2, for example. So let me just run it with SSMS. So you can see all the operation of this is done on SSMS, which is you already mostly, if you are SSIS user, you're very familiar. And when you click on this, oops, sorry, what happened? Give me a second. Oops, wait, maybe this is not the right one. Don't have the password. I forgot to put the password for the package, for the connection manager. Okay. Oh, what's happening? Oh, sorry, I forgot something else. I actually have to assign a parameter. That's why. Let's see here. Okay, now it's running. And you can see there's a pending execution there, right? It takes a while to run. Give me a second. Let's see if it's ready here. This is the destination table. Let's see if there is a result already. Not yet. That's not the one. Let's try again. Okay, so it's running. Okay, when it's succeeded, it should actually move that table from one place to another. Where is that table? Give me a second. Oh, it's in here actually. It was 1 to 1, so yes, so it's moved. So you see, you can execute the package in SSIS-IR using SSMS. But as you know, in SQL Server on premises, you have a scheduler that you can actually schedule SSIS packages using a SQL Server agent, right? And in SQL MI, Managed Instance, you have also a job scheduler called the Managed Instance agent. In Azure SQL DB, where I actually currently hosting my SSIS DB, there's no such thing, a job scheduler that can execute SSIS jobs. So the way we do it is we want to actually transform the SSIS package into an activity inside ADF such that you can use ADF feature, the trigger and scheduling to execute the pipeline, right? In the past, to do that is a bit involved. I'll show you. In the past, we used the let me see. We used the ADF store proc activity. Here, you can see here, you can get it from the general. You can just drag and drop it, for example, right? Let me just do that. So I already have this. In the past, what you do is like you drag and drop a store proc activity, you configure it, and you have to create a link service. The link service is actually telling the Azure Data Factory to connect to the SQL DB where you host the SSIS DB, and then you have to assign a store proc, for example, and then provide the T-SQL script to do it. I mean, it all works, but it's a lot of involvement. You have to create link service and you have to code in with T-SQL. What we just recently added is a new activity, which is a first-class activity for SSIS, which is here. You can see in here. Execute SSIS package. You can just drag and drop it like that. I'll show you the one that's already done. In here, you don't have to create link service or coding T-SQL anymore. All you need to do in the setting tab, you just provide the reference to the SSIS, the integration runtime name. In this case, this is my Azure SSIS integration runtime. And then you provide the path to the package. Essentially, you can see in here, right? There's a folder name, which is demo. There's a project name, which is, for this, in this case, is called a scale out project. And then one of these package name. So in this example, what I do is I provide the package name and the environment, like 1 to 2, and then I just trigger it. So when I trigger, and you can monitor the let me see. And you can see it's running in progress, right? And you can see the activity itself. It's still running. So you can actually monitor the package execution on ADF as a first-class activity. And you can even see in the SSMS too, actually. Let me just look. I have one form, right? So it's still running here. You can see the same package is succeeded, and you can see the ID is 83. Operation ID in SSMS is 83. That actually match the one in ADF app. It's done, and you can see the activity output is the same 83, right? So that's how you actually execute package execution in as an activity. Once you do that, then you know in ADF you can actually schedule it. Give me a second. Like I said before here, and you can do a new edit, and as you can see, this is I have a pre-created trigger. Then now, essentially, you can use ADF to schedule SSIS package execution in IR. One more thing that really interesting that we just launched, actually, essentially fresh today, right? Is a way to automatically generate ADF pipeline activity and trigger from SSMS. I'll show you this this new feature. You can see, for example, here. I have a package called PowerShell DTSX, right? What I want to do is I just right-click in here, and now we have this new item which is called schedule. When I click on here, we'll see. It essentially pop up a way to configure the package execution as an activity. In here, if you can read that little notes in the bottom, it will essentially automatically auto-generate ADF pipeline, ADF activity, and ADF trigger with the name of the package name and timestamp inside my in the ADF UI. I'll show you how to do that. So there is like the auto-generation, and you can configure the execution properties, and then finally you can select the schedule for that. So instead of doing it on ADF, you can do it on SSMS, and this is the same UI like using a SQL Server agent, right? Let's say it's running every Sunday at midnight, blah, blah, blah. When I click on OK, it will just confirm that it's auto-generating pipeline activity and trigger. You can see here. And then what you can do is like you can go to ADF pipeline to actually extend that activity and also change or edit the trigger. If you click yes, you see, there's a new pipeline here with the name is with the same name of my package, PowerShell, right? And it's essentially this is essentially first-class SSIS activity with the path all automatically generated, and the trigger is also automatically generated. You can see there's a trigger PowerShell timestamp, and you can see it's run every Sunday at midnight. Okay, I'll just deactivate it. Oops, sorry. Okay, how much time do I have still? Can I have one more quickly? So before I go, I have one more a demo, basically to do a custom setup. Let me just show you what the custom setup is. Okay. So what is a custom setup? Custom setup is essentially allows you to add your own setup steps when you provision or configure SSIS. And why you want to do this is essentially you want to alter the default operating configuration or environment. For example, you want to start additional Windows services. We have customer that wants to actually start a Microsoft DTC, Distributed Transaction Coordinator, for example. We have customer who wants to install additional component, and even there are customer who want to install a previous version of .NET Framework, like 3.5, because by default, IR has always the latest .NET Framework. But some customer have component that has dependency on the previous .NET Framework. You can do that through custom setup. The way you do it is you prepare a script, which is a main.cmd script, and associated files. The associated files could be the DLL that you want to install, or the connectors, or the API, etc. Upload them into a blob container, and then you provide a SAS URI when you provision or configure. You can see the parameter when you provision before to plug the SAS URI, right? And once you do that, we'll run the setup, and we will upload the setup execution logs and a standard out and standard error back to your containers. You can debug it to make sure that your custom setup is executed. And for third party, for ISV, as you know, IR is actually very volatile because customer can resize, scale out, scale up the nodes. So the traditional way of ISV to bind a license using machine name, a MAC address, etc., is not applicable anymore. So we actually provide a new way for ISV to license their components on IR, on SSIS IR. We provide a unique and persistent Windows environment and SSIS system variable for them to do that. And basically, we have two variables, which is called cluster ID and cluster node count. The cluster ID itself is very invariant. So basically, whatever you do with the IR, scale up, scale out, change the VNet or whatever, the cluster ID stays the same. So that way, that can be used by ISV to bind their license, okay? And this is like a typical way of ISV to license their component. Their customer can go to their website and buy a product, for example. And they bring the product key and have a pre-made custom setup. And he will configure his IR with this product key and custom setup. The custom setup will actually connect to the ISV activation server with the product key and a cluster ID. The ISV will make sure that this is already a paid product. So the ISV activation server will send back the activation key, and then the setup will actually store the activation key locally inside the node. And that will be used for validating package execution later on. At runtime, when you have a package that has this ISV component, the ISV component will actually check that local storage or the registry, what is the activation key and what is the cluster ID. If it's matched, then you can run a package using that extension. And that's a very simple way of licensing a custom component. And these are all our partners who are actually supporting it. So if you are interested to try, you have Theobald Software, for example. They have an ISXtract component ready on IR. You have Pragmatic Works with a Task Factory, CozyRock with Dataflow Plus, Echosoft, Kingswaysoft, and Zapier. And Zapier. More coming soon as we go along.
To roadmap now, and in last 5 minutes, and we can open up for questions. So we talked about what we have done on the ADF side, what we have done in terms of enhancing SSIS and lifting and shifting those SSIS packages, data movement. So what are we doing next, what we have done so far, and what are we doing in the coming months? So these are the different buckets on the left that you see. The first one is control flow. So we have the entire control flow canvas released. You saw that we can drag and drop. We have 20+ activities over there. They are growing. We already announced the Azure Databricks integration, so you can use Notebook as a step in your pipeline to prep the data, transform the data. The file arrival trigger, I showed you the event-based trigger. If your file lands in Blob, you could trigger a pipeline. We just released it. We are working on scheduled roll-up trigger. So if you have like 24 slices of data, and once, let's say your data is coming every hour, and once 24 slices of that data is ready, then you want to trigger the downstream pipeline. We are working on a roll-up trigger like that. In terms of data transformation, so this is the biggest piece that we are working in ADF this year, where we are working to give you a visual data flow, where in ADF today, you can just drag and drop control flow activities, but let's say you want to sort, merge, join, filter your data, you still have to write either a stored proc or you have to write a Spark code to do that. But imagine that data flow heading, which currently just has the copy activity, gets filled up with all those transformations, and those are all visual. So you'll be able to drag and drop those, and behind the scenes, we'll automatically run it over Spark and scale it out for you, scale up, scale down, and take care of all of that for you. So we are working towards that visual data transformation this year, and you'll see us releasing that towards the later part of this year. Then data movement, we continue to add more connectors to the data movement piece. So the hybrid connectivity piece continues to grow. We continue to add more regions. We are in 20+ regions today, and we will continue to go wherever Azure goes. We will also continue to work on increasing the performance of existing connectors. I showed you one example today with Cosmos DB, where we have increased the performance 10 times. And just like that, based on customer requirement, based on the needs from our partners or developers like you, we'll continue to increase the throughput of the existing connectors as well. Then in terms of SSIS,
in terms of SSIS, as I mentioned before, there's more region and VM choices coming. Enterprise Edition has been released. Azure Hybrid Benefits has been released. Custom setup and third party, I just mentioned before. I didn't get a chance to demo the custom setup, but this deck is really big because there's a lot of like a demo screenshot that you can go through later on at your own pace. So please take a look later. And finally, with the first class SS activities, you can actually start combining stuff. And I would just want to show you a quick picture of what it looks like. You can see here, this is like one of the way to modernize your pipeline. In the middle is you have this first-class SS activity that execute package anything, right? But what I do is I sandwich this SSIS package between two web activity, and this web activity has a webhook that actually run Azure Automation runbook that has a PowerShell to start and stop IR. So remember before, instead of like manually stopping the IR if there's no workload, you can actually start it just in time before your package execution and then stop it just in time after your package execution. So it's almost like a on-demand, just-in-time IR provisioning. So this is there's a lot more way of modernizing your workflow, combining SSIS and ADF activities.
So in terms of tools, I already showed you the visual tools that we announced in January. We'll continue to enhance those with more activities. The programmatic interfaces are there already for you to use. With respect to source code control integration, I showed you that we are already integrated. The visual tool is integrated with VSTS Git. We are actively working to integrate it with GitHub as well. So you'll see that coming in the next few months. And in terms of monitoring, I showed you a simple list view-based interface. We are also working on having a single pane of glass for you to monitor and manage it and look at all your executions, look at the metadata, compare runs. All of that is being worked and will get released later this year as well. With that, we are pretty much at the end of the session. So if you have any questions, feel free to ask now. We'll be hanging around over here for a few minutes. So if you have any questions, you can ask those as well. Do you want to speak at the mic, please?
Two questions. You presented Databricks activity.
Yes.
Are you planning to have Spark execution, but not on Databricks? Suggest, let's say I have a Spark cluster, but it's not on Databricks. It's just my own Spark cluster. Is it possible to integrate execution from Data Factory? And the second question is about integration with Event Hubs.
Okay. Yeah, so to answer your first question, today what we are going towards in this year at least, and we are still not finalized the next month plan, but I can tell you till June, we are just working towards integrate with Azure Compute. So what you are essentially asking is bring your own compute, that if you have some compute running on an ISVM in Azure, can I send my activity to that? You can do it through our hooks that we have, like the web activity that we have, where you can call an HTTP endpoint, and that endpoint could be running with your workload over a Spark cluster that's running on an ISVM. But there's no direct hook that we provide. But there are ways that you can use today with Data Factory, web activity, custom activity that we have to do such integration. And the second part that you have, the second question was, will we integrate with Event Hubs? So it is on our roadmap today, but it is not going to be done by June, but eventually later down this year, we will do that integration at some point in time.
So I remember on the pipelines you showed how to kind of custom handle errors. Are there any standard error handling, retry logic at the orchestration level, retry every minute for 10 minutes, anything like that?
Yes, so if you look at the pipeline level, we have the ability for you to specify those retry, and you can specify the retry interval as well, and we will guarantee you that we will retry for that many times for your activity, for your pipeline to execute.
And is there visibility at a monitoring level of that at a macro standpoint at this point, or is that only in the future?
Yes, so we already have APIs where you can get that data. Plus, one of the other things that we have done as far as every Azure service is concerned, that we have integrated with Azure Monitor. So using Azure Monitor integration, we generate all the metrics, and you can route using Azure Monitor to OMS, Operational Management Suite. And there you can essentially have Power BI heads, Splunk heads, or you can do complex querying where you can say, if my pipeline X fails for greater than two times, then I want to send an alert. So you can do all of that with that integration as well. Right. Any other question? All right, thank you, folks. Thank
Thanks,
you for
guys.
coming in.
Appreciate it.